In this topic, you can see that there is a non-conducting disk. है ना? Okay, this is a non-conducting disk, and this disk is rotating about its axis with an angular velocity of omega. If the radius of this disk is r and this is a non-conducting disk but it is uniformly charged and its surface charge density is sigma, so we have to find out the net magnetic field due to this rotating disk at this point, which is the axial point. So I think that you could understand the situation and you could see that we have to consider an element to integrate. Okay, because we have to find out the magnetic field due to the disk, and we can consider a disk to be formed of many small rings which are of different radius. So let us consider a ring of radius dr, in fact of thickness dr and radius r. So if we find out the charge dq of this small ring, then dq will be dA into sigma, and the area of this ring will be 2 pi r into dr into sigma. This is dq, so dq will be 2 pi r sigma dr, and this along with the disk, this ring will be rotating, and therefore we can say that the current that is generated due to the rotation of this charged ring di will be dq omega by 2 pi, which is the average current. So di will be equal to r sigma dr, cancelling 2 pi with 2 pi. So this is the small current that is generated by this ring, and the magnetic field created by this ring on this point P will be mu naught into di into r square upon 2 r square plus x square to the power 3 by 2. Okay, so dB will be mu naught and di will be sigma r cube dr divided by 2 r square plus x square to the power 3 by 2. Okay, so now to find out the net magnetic field B, we need to integrate this term, which is mu naught sigma by 2, and this is r cube dr divided by r square plus x square to the power 3 by 2. Okay, and to integrate this term, let us take mu naught sigma by 2 outside the integration, and inside it is r cube dr divided by r square plus x square to the power 3 by 2. Okay, and you can see that if let us assume that z square is equal to r square plus x square. Okay, so 2z dz will be equal to 2r dr. You should always remember the fact that here the variable of integration is a small r. It is not x. In fact, x is constant distance of this point from center of the disk. So we should always integrate about r. So dB, in fact, b will be equal to mu naught sigma by, this is 2. Sometimes my 2 appears as z. So this is a real cause of confusion among the students. So we can say that r square is equal to z square minus x square. So it would be z square minus x square divided by, in the denominator it would be z cube, and r dr will be equal to z dz. This is z dz. So b will be equal to mu naught sigma by 2 integration of 1 by z minus x square by in fact it would be 1 minus x square by z square into dz, and b will be equal to mu naught sigma by 2 z minus x square, and the integration of 1 upon z square is equal to minus 1 upon z. So it is plus 1 upon z. And z was r square plus x square. So b will be equal to mu naught sigma by 2 r square plus, in fact what we can do, we can take the LCM, so it would be z square plus x square divided by z, and b will be equal to mu naught sigma by 2 r square plus x square to the power half, and in the numerator it would be r square plus 2x square, and the limit of r will be from 0 to r. So finally b will be equal to mu naught sigma by 2 and r square plus 2x square divided by, let us use the next page, 1 second, yeah. So b will be equal to mu naught sigma by 2 and r square plus 2x square upon r square plus 2x square upon r square plus x square to the power half. So let us apply the limit 0 to r. So b will be mu naught sigma by 2, and in the numerator it would be r square plus 2x square, and in the denominator it would be under root r square plus x square minus, if we substitute the value of r as 0, then it would be 2x. You can see that. So this will be the net magnetic field, and at center of disk x will be 0, so b will be equal to mu naught sigma by 2, and as x is 0 it would be equal to r only. And obviously I forgot to write, there would be a omega also in the complete expression, which I forgot to write down. So there will be a omega also. Okay, so this is omega. I am writing it down. This will be the omega. So this will be the final expression along with omega. Thank you.